Periodic motion is the motion which repeats itself at regular intervals of time. Such kind of a motion is called as periodic motion. The oscillations which can be expressed in terms of a single harmonic function, may be a sine function or a cosine function. Such kind of a motion is called as harmonic motion. The external force or a vibrating system, it forces another system in order to vibrate with a greater amplitude than the specified one is called as your resonance. Hello everyone, I'm Brinda from Department of Physics, welcoming you all to Chapter 14, that is Session 1 of Chapter Oscillation. Today in this chapter we are dealing with what exactly is the motion, that is there is a different type of motion called as a oscillating motion. With respect to it, we have a confusion with respect to periodic motion as well. So there is a difference between periodic motion as well as oscillating motion, which means to say periodic motion is the motion which repeats itself at regular intervals of time. Such kind of a motion is called as periodic motion. For example, you can take planets revolving around the sun. And next is oscillatory motion. In case of oscillatory motion, the movement of the body is from back and forth repeatedly about a mean position. So suppose if there is a mean position, that one position is called as mean position. So there is back and forth movement. Suppose if you consider a spring, as you pull the spring and leave, it will have back and forth movement. Back and forth movement. If it is a simple pendulum, this holds good as a mean position, and there is a bob over here. So to and fro movement of a simple pendulum. Such kind of a concept is called as your oscillatory motion. So above that, in oscillatory motion or oscillation, we have a concept called as a harmonic motion. So we need to know what is meant by this harmonic motion. To know this, the oscillations which can be expressed in terms of a single harmonic function, may be a sine function or a cosine function. Such kind of a motion is called as harmonic motion. In this, it has got a constant amplitude and frequency. So in order to know what is this amplitude as well as a single frequency, you have your axis over here, x-axis, y-axis. We draw a sine waveform. So this sine waveform will have a constant amplitude. Amplitude means the height. This height is called as the amplitude, and the frequency is the time period which is taken for the cycles, which in 1 second, how much of cycles it is been producing. Such kind of a concept is called as your frequency. So now let us study what is meant by period and what is meant by frequency. One complete wave is set up in a medium. That is the time period. That is, suppose if you consider this axis as previous, x-axis, y-axis, origin. This is the waveform, and this is 0, 0 to, this is pi, that means 180 degree. This is 2 pi, this is 3 pi, it goes on. So the center of this is 90 degree, 270 degree, so it is pi by 2, 3 pi by 2. So one complete wave is set up. That is, what is a one complete wave? That means one complete circle. This is 2 pi degrees. So one complete wave, circle wave means it is this portion. So from here to here, it is known as time period. One complete wave is set up in a medium, that is called as your time period. This is your time period. So what is this frequency? Number of waves set up in a medium in 1 second. Suppose these many waves are set up in a medium in just 1 second, then I can consider this as frequency, which is given by nu, or it is also called as f. So frequency is always reciprocal of the time period. This is the relation between frequency as well as the time period. Frequency is given in terms of nu, or else you can even write f is equal to reciprocal of time period. So frequency is equal to reciprocal of the period. That is what I have mentioned over here. That's all about your period and frequency. And what is the simple harmonic motion? Defined as Oscillatory motion, which is about a fixed point. The fixed point is there and oscillatory motion is this. Such kind of a motion is called as a simple harmonic, and a fixed point is also called as nothing but the mean position. So there are some criteria for this. The restoring force is always proportional to the displacement. That is, the restoring force is directly proportional to the displacement, which is equal to F is equal to minus K and X. Why negative? Because the force is called as a restoring force. It is restoring back. That is why it is called as restoring force. And it is always directed towards the point, towards that point, in the sense, which point? It is the mean position. That means whenever there is a simple pendulum, bob starts moving from this place to this place, again it restores back. So restores back to the mean position until and unless it comes to this rest position, or it is also called as mean position. This keeps on moving. So next is we need to know certain terms and conditions for this chapter. Like there are certain set of terms like period, frequency, amplitude. We need to check what is it. So there is a axis, x-axis, y-axis, and this is negative y-axis and negative x-axis. This is the origin. So we need to have only this set of conditions. So we have a wave, call it as a sine wave with the constant amplitude. The height of a waveform from an origin is called as amplitude A. And the frequency in 1 second, how much of wave we get is known as frequency. Amplitude is this. And period is, to complete one complete circle, what is the time taken is known as time period. And phase is nothing but the directions of it. So now we know, by having all this set of equation, let us just derive the expression of our oscillations of a simple pendulum. So we know this is a simple pendulum which is with respect to an angle theta. The length of the bob is said to be L, and here you have a bob which moves towards this side. There is a tension which is created. Always remember the tension is along this line. So we have mg sin theta, m cos theta, and mg over here. That is the actual force acting downwards. Resolution of that force. So resolution of a vector mg turns out to be 1 with respect to mg cos theta and 1 with respect to mg sin theta. So we have a equation over here, that is mg sin theta, mg cos theta. So now let us just check what exactly we are gonna do with this. So first of all, we just consider when a bob is moving here, it is again restoring back. So we just take this path, that is mg sin theta. We know that f is equal to, f is directly proportional to x. So it is minus k of x. So this content is nothing but f is equal to your minus mg sin theta. Since the angle made is that is the displacement angle is very small, sin theta becomes approximately equal to theta. So we get it, f is equal to minus mg theta. This is one set of equation, call it as equation 1. And we also have force is equal to mass into acceleration. So acceleration is equal to force by m. So force is nothing but minus mg theta divided by m. M cancels with m. So acceleration is equal to minus g theta. So we know theta value is x by L, because x is equal to theta by L as well. So due to this we have A is equal to minus g of x by L. So we have this set of acceleration with this. So as we know that the acceleration in case of oscillation is nothing but acceleration is equal to square of angular velocity, negative of angular velocity with respect to direction y. So here, since we are considering x path, that is negative x-axis or x direction, we have A is equal to minus omega square. Instead of y path, we consider x path. So this is another set of acceleration what we have. Let us consider this as equation 2. Let me consider this as equation star. Equating star as well as 2, we have minus omega square x is equal to minus g x by L. Gx cancels with x and negative negative goes. Omega is equal to root of G by L is what I'm having. So omega is nothing but, it's known as, omega is nothing but 2 pi by T concept. That is the formula of this, 2 pi by T. So when I just write it, it becomes 2 pi by T is equal to root of G by L, and the time period goes towards other side. So time period T is nothing but 2 pi root of reciprocal of G by L is Lg. So this is the time period of oscillation. So what was there for us to find out? Expression of oscillations, that is time period of oscillation, we'll have to find out for a simple pendulum. So this is how exactly it goes, and it is very easiest one. Next is, what is meant by damped oscillations? If the amplitude of SHM, as you all know, simple harmonic motion, SHM is a simple harmonic motion which has a constant amplitude as well as it has got a single frequency. Such kind of a concept motion is called as a simple harmonic motion. So if the amplitude of a simple harmonic motion system varies, that means increases or decreases with time, finally it dies out. Such kind of a motion is called as a damped oscillation. That is, it goes on decreasing, increased form, finally it goes on decreasing. This is called as damping of the oscillation. It causes reduced in the amplitude, that means the height of the oscillations reduces. There are 3 types of damping, that is, one is light damping, heavy damping and critical damping. Those are 3 sets of damping. Next is, we have types of oscillations. One is free oscillations, another one is forced oscillations as well as the resonance. So what is meant by free oscillations? It's a system which is oscillating with its own natural frequency. If it has got, that is called as free oscillations. Forced oscillation means the body is maintained at the state of oscillation by some external aid or a external force of a frequency other than this natural frequency. If it has got some external pressure because of which again external frequency is acting on it, such kind of a frequencies are called as forced oscillations. Next is resonance. So resonance is nothing but the external force or a vibrating system. It forces another system in order to vibrate with a greater amplitude than the specified one is called as your resonance. So for these two, there is a external conditions of the frequency or the vibration which is given, wherein for free oscillations it is nothing but just it vibrates with its own frequency concept. So in today's class, we have dealt with the chapter oscillations. Let us all meet in our next upcoming session with the next upcoming chapters. Until then, have a good day. Thank you.